Good morning. My name is Alex, and hey, and I work for Astra Digital. At Astra Digital, we build satellites, we operate satellite missions, and we deliver the data in up to analytics-ready data sets, include and other more early levels of processing. Today, I will be talking about our Landmapper BC constellation and how we fit it to adjust this to ingest it into the analytics-ready data set for the community for different use cases. So a couple of words about the Landmapper constellation. So this is a satellite multispectral imaging system with a 22 meters resolution in 3 spectral bands, red, near, and green. So we have a wide swath of 220 kilometers, and we plan to launch 10 of the satellites. So currently we launched the first one, and we are excited to start getting the first images for this satellite. So this is a system of small sats. The cameras are able to image in the radiometric parameters consistent to Landsat. So we are looking forward to ingest into the currently mostly available or mostly used in the industry data set. The satellite is equipped with a K-band, and we already tested it, and it's working. So we are confident that we can downlink everything we image. Regarding the applications for our data is the mapping, including the mapping for agriculture, for seeing the vegetation, mapping for irrigation systems, monitoring of the natural disasters, and one of the most interesting for us and the challenging application is the building analytics models, mostly statistical models, which requires to compare current location with other locations and compare today's observation with the previous day and the previous year, and be able to see what's happening in the future. So for all these use cases, the strong radiometric characteristics and compatibility of the data and consistency with other available data sets is really required. So at Astra Digital, we are looking forward to make Landsat and Sentinel data richer and bigger to overall have the most dense and consistent data set, because for agricultural monitoring, there are really certain pivot points which are critical to monitor, to see, to expect, and to predict how the productivity will look like this year. We are really excited to have the first data from the first satellite. So we had the successful launch in January, and with that satellite is operating, and we started getting the images from it. One more satellite is going to be launched this November. So by the end of this year, we'll have imagery with 2 satellites. So this image was taken here in California. So there's a really bad and disastrous car fire. We processed the image into red, green, and near composite. And the bright areas show the vegetation, and the smoke, unfortunately, is there because it's really a large damaging fire. We were able to downlink this shot in 90 minutes after the imagery, and for our operational, it's really visible that we are ready to deliver the data same day. So we are ready to provide this data not only for statistical applications, but for emergency response for really urgent types of the workflows. And regarding the ARD initiative and being able to use the data for analysis, we define our product for it, and there's certain challenges we need to take, and the way how we approach it. So they basically are: we need to have a grid, very likely UTM-based grid, to have the data in a squares, in a shapes, to be able to compare them one together. Then the atmospheric correction, because for most of the analytical workflows, when the radiometric is really critical, and we're talking about the 22-meter medium resolution data, the radiometry is really critical. Then we need to do the cross-calibration. So our sensors are designed to be consistent with Landsat, but the industry is obviously getting towards the Sentinel-2. So we also need to understand how to have our data be comparable with Sentinel. And also one thing is really interesting for us is how can we tune the imaging schedule to make the data set richer. Because for some use cases, we want to fill in the temporal gaps between Landsats and Sentinels, because for some equator-based locations, we want to provide the most frequent imagery, and we want to image the days when there's no Landsat or Sentinel. For other use cases, it's more important to image the same day when there's, for example, a Sentinel shot, but slightly in a different time because the clouds are moved pretty fast, and the image which was taken like in the 30 minutes can be really useful to fill in the gaps. So this is something we are really looking forward to, like in our way to make the data set richer. And how are we going to address these problems? So the MGRS is a system which is like sort of the UTM notation, which helps to consider the landmass as a series of flat squares. And for each square, we can provide like stream data from different locations, and someone can take the square and take all the dates and the whole like time series of these images and run the analysis, and to consider for a given location all the different days as different data points. So this will be our delivery, like standard unit for the delivery. Then regarding the atmospheric correction, this is an example of LaSRC algorithm for Landsat 8. So while we are looking forward to apply the same method for LandMapper, we tried with Landsat, and obviously this brings really amazing results because it helps not only to see through the atmosphere, which is visible that the right image after this correction applied looks brighter, but what's more important is that it also helps to get rid of the sensor effect, get rid of the camera effects, which may happen, and also try to adjust the differences in acquisition time. So exactly the same example in a just red band, it's really visible that, no, it's not that visible. So basically on the left picture, there are strips caused by the camera effects, and on the right picture, it's really visible how they change. I can maybe show it later on my laptop, so realize this is a visible change. And having this algorithm apply helps us to bring to the analytics-ready data set. And the last step is doing the actual final sensor correction towards Landsat 8 or Sentinel-2, depending on the use case and depending on what data is mostly used for current use case. And one of the most exciting and the really cool thing, this is our first shot. It's again, so it's comparison of LandMapper and Sentinel. So our image is slightly off nadir, and for it we applied only the flat field correction, and we did a manual author. So this is still work in progress, but we are really excited that our first results are like this. So in our plan, we are currently making our data delivery more operational. So we automating our scheduling. We automating the other steps of processing and the correction of data, but like we are really excited with these results because radiometrically this looks really consistent with Sentinel. Thank you.
That's great. Nice short presentation. Do we have any questions?
So what are you doing for validating your geometry? What's your validation process?
So for this image, we didn't do the sensor correction yet, but our first upcoming goal is to image the reticle net spots, like one in Nevada and several others, and to do the correction against them. And later on, we'll compare the L1C product towards L1C Sentinel product.
So you said you did a manual ortho correction. That will get automated. I'm just thinking from an ARD standpoint. Obviously, geometric registration is critical to be able to do the time series, and then obviously radiometry is critical as well to do the time series. So, do you have a plan all laid out for how you'll do that? How you'll do the geometric registration, pixel-to-pixel registration, things like that between 22 meter.
Sure.
10 or 20 meter Sentinel or 30 meter Landsat?
Yeah. So basically, first, as I said, our first step to do is the sensor correction towards the real energy values, because this is just like what our camera sees. It's not corrected yet. The second step is the geometry. For geometry, we will use SRTM model as our first step, and in about a year from now, we expect to do the geometric correction towards the Sentinel-2 because it has a higher resolution, and from our start tracker we get the data with 100 meters accuracy, and given this accuracy in this 100 meter area, we'll adjust towards the 10 meter using Sentinel. And after that, we will use again Sentinel to do the radiometric correction. At first validation and then maybe correction.
Do you have some specs that you're shooting for? Can you share a little bit about geometric, radiometric, all those kind of quality metrics that you're shooting for ultimately?
Unfortunately, not yet. We didn't image the proper calibration spots, so we don't have this information yet. So we.
I'm not asking a different question. I'm asking, do you have a spec that you are working towards? Do you have a goal? Have you figured out what you want to actually achieve?
Not so much, but I can share it later. Yeah, I'll see it.
Sure. Could you also, could the speaker repeat the question so that the people who are
sure.
online can understand? So, thanks. Sure.
How much would the data cost?
Okay, so how much does the data cost? It's mostly to be determined because we see our value in making Landsat and Sentinel richer, and we want to charge for someone who really uses it in its workflows, not to be really expensive on the top of this data. And this is also to be determined. But we really don't expect someone to use our data beside Landsat and Sentinel.
Perfect. I think we should probably move on now, but please direct any more questions you have to Alex in private.